Welcome to How to Become a Production SQL Database Administrator. My name is Rafael. In the next several series of videos, we're going to be looking at the concept of locks, blocking, and deadlocks. It's important for the DBA to know what these concepts are and how they affect performance and how to deal with them if they get blocking and deadlocks. So before I get into the academics of that, I want to quickly go to my SQL and illustrate a couple of things here. If I run this select statement against table 1, you'll see that I have a single row with the first name Tom. Now suppose a user comes and he wants to update that first name Tom to Sam. So he will execute the update statement and everything is fine. And it's executed well. And as you can see, it's updated. Now suppose after the fact, user 2 comes along and he wants to update the table 1 to Matt. Let's see if he can do it. And if he executes, that happens also. And you can see that it's been executed. So what you're not seeing is that behind the scenes, these updates are occurring because in the background, locks are being held and released at a very fast pace by each transaction. And if these locks were slow or not releasing, then we have performance issues. And that's what we need to find out, that whenever you have what's called locks on transactions, if they are not released, what is the situation going to be against the performance? And that's what we're going to talk about soon. So let me put that back to this. So before we get into the actual examples of that, let me look at some of the academics and understand some of the terminology. So what is the purpose of locks? Applications use data locks to control data integrity in a multi-user environment. Now, coming back here, the reason this was successful and we had no blocking or locking is because the mechanism behind it released the lock very quickly. And it was done not simultaneously. That's the key word. When users try to simultaneously update a table or update a page or update whatever, then you get what's called blocking. If you do it after the fact and it's not simultaneous, there will be no blocking. So it's an important concept to understand. So locks prevent data from being modified by two simultaneous sessions. So if at the same time user 1 was updating a F name to Tom and user 2 was updating at the same time to Mary, then obviously there's going to be a conflict and that will cause a deadlock or blocking. So in a normal environment, infrequent blocking locks are acceptable. And one thing to know, as I mentioned here, is blocking is not the same thing as deadlock. Now, I've heard many people call blocking and deadlock the same thing, but they are not synonyms. They're totally different concepts, and we'll be discussing that in a second. So remember, a certain amount of blocking is normal and unavoidable. So that's the purpose of locking, is to hold that particular object until it's completed its transaction. So what are locks? So a lock is placed on an object. Now this object can be at the row level, the page level, the extent, the table, or the database. A page obviously is the smallest unit of data, and basically it's 8K bytes. Extend is 64K bytes, and it's basically 8 pages. So just take a note of that. So a lock is placed on any of these jobs by the SQL Server. Now this is done automatically by SQL Server when any connection accesses the same piece of data concurrently. So this, I want to stress, it's happening this. When you're modifying data at the same time, then you're going to get issues of blocking and deadlocks if they ever occur. So now what is blocking? So blocking occurs when one session has a lock on an object and thus causes another session to wait in a holding queue until the current session is entirely done with the resources. And when I illustrate that in a second, you'll get that. But basically it's saying, hey, I'm doing something to table 1. Nobody can do anything until I've finished, in layman's term. Now, what is a deadlock then? So if this is blocking, then what is deadlock? Well, deadlock occurs when a session A is executing a process and when waiting for a resource used by the other transaction, and at the same time another session B is executing a process and is waiting for the resources used by the other one. Now this sounds a little confusing, and it is sometimes, but again, I'll be illustrating that basically in a second. Basically, in layman's term, session session A, or session A is saying, hey, I've got access to I've put a lock on table 1, and then session B says I've got a lock on table 2, and then each other needs the other table to complete. So I'll show you that in a second, and you'll get a better idea. Now, what are some of the causes for locks, blocking, and deadlocks? I shouldn't say locks, blocking, and deadlocks. Well, obviously, it all starts, unfortunately, with poor data design that can cripple contention. So if it's poorly designed databases, now I'm not going to get into what constitutes poorly designed databases because that's an entirely different subject. But some of the things that we have seen is poor indexing strategy, table not being what's called normalized, and this again becomes with design, and optimized TSQL code. So when the developers design codes and design databases and store procedures, that is what we're talking about, poor designing and poor SQL code. So as a DBA or as a production DBA, it's not your job necessarily to figure out the proper optimization of the code. It is your job primarily to find the proper or improper code and then talk with your developers and see how you can improve it. So ways to monitor locks. Obviously, there are going to be several ways you can monitor locks, deadlocks, and blocking. And these are some of the things that we've already talked about: the active monitor, the SQL profiler, the performance monitor, and the Sprock SP-Who2. So we'll be looking at those in a second also. Ways to avoid blocking. Well, obviously, as I've mentioned many times, there's really no concrete way to absolutely avoid blocking and deadlocks, but some of the key things you can do is use clustered indexes on high usage tables. So that's part of the DBA responsibility. Again, break long transactions into shorter ones, because obviously if you have a very long update and updating 1 million or 2 million rows, that's going to certainly take a lot longer than updating 10 rows. So you may break up the transactions. Make sure that the delete and update statements are using indexes. So we've talked heavily about what the performance gain you get from indexing. So that's an important concept. If your code allows running queries to be canceled, it is important that the code also has a rollback transaction. And this is important because if your code does not have a rollback transaction, then the query can be just running for forever. So this is all basically a developer's responsibility, if you will. But again, you work in conjunction with developers trying to figure out what the best course is for your query optimization. So this is important. Now, a couple other things, and then we'll go into the demonstration, most likely the one. Some of the locks that we're going to be talking about are exclusive locks, shared locks, update locks, intent locks, schema locks. Now, as I mentioned earlier, that when a transaction accesses an object such as a table and he's updating it, he's going to put one of the locks. And these right here, I'll let you go through what these mean, and we'll go over them later. But these are the definition of them. An exclusive lock is placed on a database object when it is updated with an insert and update. So you'll get this lock X next to the statement that you're trying to utilize. And I'll be showing you that also later. So let me see if I want to quit here and start. Okay, so one of the things I want to talk about is, what is the sign that blocking and deadlocking are occurring? Well, one of the most common things you'll find as a DBA is that the user will tell you. One of the clear things about, hey, you may have a deadlock or you may have blocking is the user will tell you, hey, I started my query and it's taking 10 minutes or it's taking an hour. That certainly is a sign for you to start investigating if it's a possibility of a deadlock or blocking. So this is a clear sign of when the user tells you, hey, it's taking way, way too long. Anytime anytime a query of any type, whether it's a select, insert, update, delete, takes more than a few seconds to complete, blocking is likely. So these are some of the reasons you're going to look into it if you have any blocking here. So let me look at the time for a second. Okay, so locks on select statements. Locks on select statement are only held as long as it takes to read the data, not the entire length of the transaction. So take a note of that. However, locks are held by inserts, update, and deletes are held until the entire transaction is complete. So this is an important concept, and this is done to allow easy rollback of a transaction if necessary. So what do you do if blocking takes time? Takes a long time. So let me continue with that, and then we'll get into the demo part here. So what do you do if blocking is taking a long time? Well, most blocking locks, as I said, go away. You didn't see any blocking or any locks here because it was such a quick update, just one single record, single row. But if blocking does not go away and is preventing one or more users from performing any necessary skill, then you have to find this culprit, which is the server processor ID, and kill that processor. And I'll be showing you how to do that also. One thing to note is that before you kill the processor, and what I mean by the processor is if a user is, for example, using a update statement, he's updating 100,000 rows, for example, that may take 10-15 minutes to update a row, or a few seconds to, or a few minutes to update. Now, if that is causing a block and you kill his transaction, you kill his what's called SPID number, then all his efforts is going to be rolled back, and he's going to have to start again. So the appropriate thing to do is make sure you talk to the user, and we'll show you where he is or how to determine that, and give him a call and say, hey, your processor is taking 10-15 minutes and is blocking other users. Can I kill it? And if he says okay, then tell him what the reason is. So this is now the next couple of videos. I'm going to be demonstrating what blocking is, and deadlock with the SSMS, and then we'll get it. So I'm going to leave it here, but I just want to quickly reiterate a few things here. So what is the purpose of locks? It must be in a multi-user concurrency, and it's to prevent two simultaneous sessions from updating the same object. So a lock is placed on every object, whether it's a row, page, extent, table, or a database, and any connection accesses the same piece of data concurrently will have locks on it. Now, what is blocking? Blocking, as I mentioned, is when one object causes another object to wait. So that's basically it. And then we've talked about deadlocks. So I think I'm going to leave it here. So this is some of the academics that we always need to understand. And I encourage you to, again, to go through this on your own time a little more deeply and kind of reread it. But you get the idea now. So the next couple of videos, I'm going to start actually looking at the demos, so you'll get a better idea of what's going on. So I'll just leave it here, and we'll pick it up in the next demo where I'll show you right here where we start beginning to look at the examples we've been talking about, blocking and deadlock. So my name is Raphael, and this is how to become a production SQL database administrator. See you in the next video.